So very excited to introduce John Froehlich. He's a professor at UW where he leads the Makeability Lab. And I also saw yesterday that you also are the associate director of the Center for, was it Research and Education on Accessibility Technology and Experiences, which looked really cool. It focuses on, yeah, I guess the mission is easy to understand. It's looking at how we can make technology more accessible and also how we can develop new technology to make the world more accessible. And yeah, I really liked the mission statement for that. But yeah, overall, John works on his work is very applied, looking at how systems or methods like AI and crowdsourcing and human-computer interaction can be applied to solve problems like environmental sustainability, accessibility, of course, and other, just a wide range of other problems. So yeah, ranging from systems, I saw there was a work from a while ago to improve the accuracy of like finding thermal insulation leaks.
Yeah, which I have a slide on.
Oh, okay.
It's as if we like collaborated on this introduction, because I will give you a taste of some of the breadth of work. I guess now that we can seamlessly have you sit.
Yeah.
It's really my pleasure to be here. This is my intro slide, and some folks might be familiar to you on this slide if you look closely. So Arnavi, who's in the back, is first year PhD student in the Makeability Lab, and I'm really just delighted to be here and to bike down the Burke-Gilman and see the water and the sunshine. So thanks for joining me, and really credit to the students here in my lab. I'll be sharing their work, which I help advise, as well as some of the students that have recently graduated. So yeah, our mission really is to look at ways that we can build interactive technology to address, pressing societal challenges. And I like to take the lens of seamlessly coupling atoms and bits together. So towards the CREATE mission, we often look at the application of technology to the physical world, or that's where the atoms come in. And we have 4 focus areas: environmental sustainability, health and wellness, accessibility, and STEM education. So I'm just going to briefly talk about these things, but largely my talk will focus on crowdsourcing and a tool called Project Sidewalk. And also, feel free at any time to interrupt me. I'm very happy to take questions. I think it's, particularly this size of audience, it's awesome. If you have a question, please do just ask it and I can respond to it. So towards this project, which you briefly mentioned. So this is this idea of pervasive thermography. So like leveraging cell phone sensors that could potentially measure thermal leakages in building and allow citizen scientists and others to start to do that at scale, perhaps, accounting for thermal leakages in government buildings or other kind of public buildings. So that was my PhD student, Matt Moriello's dissertation topic, and now he's a professor at the University of Delaware. And towards health and wellness, we did a lot of explorations of electronic textile displays and the ways in which we might imbue them on the human body, for example, to support group running. So here we're allowing group runners to have a shared goal, to be immersed in the experience of running and not in their technology, and to get heads-up displays about how their group is performing. And of course, these things also interplay with one another. And I think these sort of connective tissues are maybe where the most interesting projects occur. So this project is called BodyViz, also an e-textile. And the idea here is, can we allow children to learn about their bodies and scientific inquiry through physical activity? So again, as they're embodied in the world and engaging in physical activity, these shirts will respond. This is a very early prototype, and here's a later one. So here it's responding to the physiological signals in real time as the wearer is moving about, and they might hypothesize, how is my body changing? And I read versus when I'm running or doing jumping jacks. And one cool insight that the student Layla Nuruz had when working on this is that we could make it actually a puzzle. So dynamically, it will respond if you can rebuild the shirt, and if you appropriately place your anatomy back together, the shirt will instantly respond. But really, I'm here to talk today about accessibility, and particularly how we can leverage advances in computer vision and human-computer interaction to make the world more accessible. I'm going to talk about 3 briefly, and then we're going to dive into our work on sidewalks. So this one is a new large-scale research agenda looking at how we can use real-time computer vision and augmented reality to broaden sports participation. So you're seeing behind me 2 people playing tennis, one person for the first time. who has low vision, and he's wearing a head-mounted display, and he's getting real-time information about where the ball is, right? So we can really try to augment people's existing senses to try to broaden sports participation. Here's another one. This was done by my PhD student, Dhruv Jain, when he was a PhD student here. He's now a professor at University of Michigan. And here the idea is, can we utilize real-time sound recognition algorithms? And here we have a custom trained model running on the watch and on the phone to recognize sound and provide sound feedback to people who are deaf and hard of hearing. Insert cute animals. Oh.
Aww.
So we have active work that we're submitting to assets next week on personalizing these models so that it can recognize your dog's bark or your cat's meow or your kid's cry. And then some recent work in looking at indoor accessibility assessment, again, leveraging increasing cell phone sensors that are in the iPhone. Here we're doing an accessibility scan using both LiDAR and real-time computer vision.
Start. Please point camera at top and bottom of wall to initialize. Table.
The 3D reconstruction is here.
Detected throw rug. It's a tripping hazard. Table. Share.
Finish button.
Scan finished. We detected 3 issues in total.
Then at the end of the scan, you get an interactive view of that 3D reconstruction on all of the identified problems. So you'll notice that it observed that there was a tripping hazard with the rug. It also observed that potentially there was a problem with the table. Does anybody know why that might be an accessibility issue?
The age.
Sorry?
The age of the table.
Edge, definitely that's a safety and danger concern for somebody who's low vision. That's not why it identified it in this case.
You show the.
I know, it's like, well, probably not, you know, how do we get to it exactly, you know? It's like, where was it?
Is there insufficient space to navigate around it?
There is, yeah, I mean, that's definitely a problem. I don't think it picked that up on the scan. That's also something that we're doing in our 3D reconstructions. But in this case, it's because the table height is too low for somebody in a wheelchair. Awesome. Great conversation there. So I'm going to have a couple of call and responses like this in the talk because I am an educator and I find it useful. But really, the primary thing I'm going to talk to you today about is the built environment and sidewalks. And just to motivate this work a little bit, you know, sidewalks are critical public infrastructure. Maybe many of you took them today. You know, they're a last mile, first mile conduit. They're kind of a lubricant for our cities, but they're also often overlooked. And this is particularly problematic for the 30.6 million people in the United States that have mobility disabilities who really rely on sidewalks. It helps increase their independence, their quality of life, and physical activity. But a lot of sidewalks look like this, and particularly in Seattle. This is a famous archived picture at the Smithsonian from the disability rights movement. Does anybody know what's a problem here?
Curb cuts.
Curb cuts, yes. So we have a designed environment. People invested time and energy into thinking about how to design a sidewalk, but they didn't put in a ramp. Okay, so there's no way for that person in a wheelchair, a manual chair, to get down. This is a far more recent picture from Manhattan in New York. Again, no curb ramps. Here we have a curb ramp, but unfortunately we have a pole. Here's another issue. Somehow we have an abruptly ending sidewalk. Maybe we've run out of pavement or concrete, or maybe it's a split in municipalities. So that sometimes happens where cities don't really have a good trade-off or an effort to work together. Surface problems, particularly problematic in Seattle with, you know, trees will always win and these uplifts. Or sometimes we have issues like this, both degradations and built environment design problems that fundamentally affect people. And so you might ask, well, how do inaccessible sidewalks impact human mobility? Well, we've been working on this problem for a long time, and we've conducted interviews and workshops with over 150 people, which is pretty fascinating just to reflect on that number. I'm going to share some of the thoughts and first-person perspectives of people with disabilities.
When I go to school in the mornings, I don't take the sidewalks. I actually take the street, and they shout at me from their cars. They're like, "Get off the road!" And it's like, I can't actually use the sidewalk.
So someone who can't actually use the sidewalk and then is actually yelled at for going onto the road so that they can just be mobile. This one's from Disability Rights
My
Washington.
name is Cecilia, and I am a quadriplegic, use a manual wheelchair, and live in the Roosevelt neighborhood of Seattle. A huge challenge, being in a manual wheelchair for me is when the sidewalks are uprooted and are sloping downwards. It's really, really hard to push a wheelchair when you're fighting two slopes. It makes it even more challenging when you are fighting that in the rain, or when you have groceries on your lap, or when you're going over these uprooted sidewalks and your feet fall off your.
And the last one.
My power wheelchair for pretty much getting anywhere that's close distance. So I rely heavily on sidewalks to be complete, to be maintained. But since that's rarely the case, it often forces me to go out into the street, which is not safe for me. And definitely every trip I make, I'm out on the road for some reason or another due to the sidewalk conditions, whether there's no curb cut, whether there's, trees.
And I've certainly been on trips with people where we're walking together or we're rolling together and we have to turn around. So these are major problems, and they're major problems with how we equitably design the world around us. But this has long been a battle in the United States. So the disability rights movement borrowed a lot from the civil rights movement and nonviolent protests. I'm particularly enthusiastic about some of these protests that got a lot of local press, where people were going in with sledgehammers and basically making rogue curb ramps in their neighborhoods. And then, of course, this led through a lot of great advocacy and steadfast activism to the ADA, which was passed in 1990, which was directed towards trying to create a more inclusive society for all in the United States. But sadly, more than 30 years later, we're looking at a world that I showed you previously. Lack of curb ramps, lots of degradations. And generally, the only way we get big movement is through the threat of litigation. That's partly because the ADA falls within the DOJ for implementation. So Seattle lost a major lawsuit, but this is huge capital lawsuits, right, to try to direct attention. And the United Nations also, in their new urban agenda, state this design and accessibility contributes to and further reinforces systemic inequalities in economic opportunity and access to basic health and educational services for people with disabilities. But it affects all of us, whether or not we have a mobility disability, when we're taking our luggage, when we're pushing a grocery cart, when we're riding bikes with our family on sidewalks for safety, when we're walking to school, or when we're running. That person might look familiar. It's really easy to shoot videos like this in Seattle because there's so many missing curb ramps. But the problem is not just a lack of accessible infrastructure, it's also a lack of data. And that excites me because I am a computer scientist and I like data, how to collect it and how to analyze it. The National Council on Disability notes that there is no comprehensive information on the degree to which sidewalks are accessible in cities. And my colleague, Yochai Eisenberg, a professor at the University of Illinois Chicago, studied this. Cities must have ADA transition plans for their sidewalks. Sadly, though, 13% of the 401 studied had them, and only 1.7% met the minimum requirement. Moreover, when you look at open data in many cities, yes?
1.7% of cities or 1.7% of plans?
1.7% of the plans, I believe. Yeah, I'd have to look at the original, probably in the abstract, but it's too small in the screenshot. Great question. But either way, it's not a lot. So, and this is about open data. Okay, a lot of cities, like you can go to dc.data.gov, you can go and also get open data from Seattle. So there's this study, stratified sample of these open data sets. And what you find is, again, a leaning towards open street data, 54%, far less around sidewalks, and certainly far less around accessibility information like curb ramps. Now you might ask, well, what is state of practice? State of practice generally is a walkability audit. Has anyone done that? Where you go out, and it could be with an advocacy like Safe Routes to School, it could be with an advocacy group, or it could be with your government, your local government. You get a checklist and you evaluate the built environment for safety and accessibility. So Seattle did one. They gave a whole bunch of interns iPads. And this is in 2017, it cost them $400,000, but they've not repeated it. So 2017, here we are in 2024. They did value the sidewalks at $5.6 billion. So again, large capital infrastructure. So in my lab, we're pursuing a twofold solution. And the first part, and this should hopefully excite you, which is what can we do about this from an algorithmic standpoint? Can we combine machine learning and crowdsourcing with these existing streetscape and satellite imagery data sources to find out more about inaccessible built infrastructure? And secondly, then, what can we do with this unprecedented data? So I'm showing in the background a beta version of Access Score that gives you a personalized interactive view of the accessibility of your neighborhood that's also weighted by things like obstacles and surface problems and so on. And so our overarching goal is to map and assess every sidewalk in the world. I think this is a really ambitious aim, but it's one that I still find quite motivating. And hopefully this would then serve to have new types of interactive tools. Imagine routing based on your mobility. And because all of our things are image-based, we could even show you what an upcoming problem looks like and that you could make an informed choice about whether or not that's actually a problem for you, or new types of urban analytics that do a much better job of incorporating accessibility information. And we've been working on this for a very long time, since 2012. It was my first NSF grant. This is the first code commit on Project Sidewalk. And most of this research has either contributed to Project Sidewalk or benefited from it. And I invite you to try it. It's a public tool, projectsidewalk.org. But the idea here is we have this online map imagery. Then we have different types of remote crowdsourcing interfaces with tasks. And then we use that labor to try to train machine learning algorithms. And hopefully the outcomes are around improved urban planning, interactive visualization tools, new urban analytics, and improved government accountability. There's just so few tools that allow us to see whether or not governments are doing what they promise. So how do you use Project Sidewalk? Well, we've designed it kind of as an interactive game. And there's two types of data collection missions. The first is around labeling. And the second is through validation to try to improve our data quality. So let's take a look at the first. The first mission is an interactive tutorial. It's kind of like when you download an app these days, you get kind of heads up information about how to use that app. And we do the same thing here. It's difficult. We need to train you both on how to analyze the built environment for accessibility, something that you probably have not done. And we need to train you on the interface. And we need to do that in about 4 minutes or we lose you. So it's a difficult interaction design problem, but I think the tutorial is fairly good. And then we give you your first mission, which is intended to be short. And you can complete it in roughly another 4 minutes. And this is what it looks like. So here, someone's evaluating Oradell, New Jersey. And they have clearly a surface problem, so they're marking it as such. And then they turn around and they look over on the other side and they see a lack of sidewalks. And now they're labeling missing sidewalk. Ah, here we have the abruptly ending sidewalk, right? And so they'll label it with that. We have 7 label types. We have these mission stats, which also tracks your accuracy and gives you feedback. This directs you where to go, the mission map. So how do you know where to go in the virtual world? And we have a route allocation algorithm for that, and then the labeling area. So imagine that you're a user. What do you see here? Yes, I know it's so sheepish. I was like, I don't want to be wrong. I think I see something. And yeah, usually this one's spray painted. So usually that means the city knows about it, but it might stay that way for a long time. But yeah, there's a surface problem. Did everybody see that? Which is a tripping hazard and also an accessibility issue. So you would click surface problem and then you get a dialogue, a context menu like this, and you could rate the severity on the passability of that for somebody in a wheelchair, add comments and tags. How about this one?
No red.
Oh, there's so many things going on here. This isn't our deployment in Mexico, but yeah, just focus on where the blue obstacle dot is. The pole. Yeah.
Also super narrow.
There's so many issues in this particular city. So this is in La Piedad, which is in the southwestern part of Mexico. But yeah, so just in this case, we had this pole obstacle, very narrow path, but this would be impassable. This would be the kind of thing that if you were in a chair, you'd have to turn around and hopefully find a curb ramp. But as you've noted, there's no curb ramps in this intersection. Yeah.
So the overall idea is to bring more attention to the governments with this tool, or to bring more attention to like people who are living with disabilities, or in terms of like which cities to live in? which one is the main target?
There's so many different things we can do with this data, right? I think once we have the data, it can be very empowering. So one, it wouldn't hopefully necessarily be where to live, but it might be where to visit or where to plan a hotel, right, within a city. It could be to inform urban planning within a city. It could also be in support of these lawsuits, these litigations. There's just a lack of tool to help drive that forward and do data-driven analytics. So I think there's a wide range of things, and I'll get into some of the limitations if I have time, about cautioning us to use this particular data set around real-time routing. Because things like weather, construction and other things that we don't actually have access to might impede paths, and we wouldn't want to necessarily direct people otherwise. Yeah.
I guess related to that, you showed a video from Disability Rights Washington.
Yeah.
Does Project Sidewalk partner with any policy organizations or litigation? Like, is there a theory of change that's kind of worked out for Project Sidewalk, or is that future problems?
I will get to that. I think it's really complicated, and we've had some successes, and we've certainly had some failures. But we kind of have a list of considerations. What works best is generally we do partner with community advocacy groups mostly, and hopefully also the city. Because if the city isn't on board, we can do all that we want, but they may or may not actually impact change. So, but I'll get to that. I have some case studies, hopefully, that I'll have time to share. But it's a great question. It's also very complicated.
There's a question on the, I think Matt had a question.
Yeah, do you want to unmute it and ask Matt?
Oh yeah, I'm sorry. My question was, how do non-wheelchair users best assess these? Like, I'd imagine that they're not always as obvious as like a pole in the middle of the sidewalk.
One more time on your question. How do people who are not wheelchair users assess these?
Yeah, like best assess them. I guess like I worry about able-bodied people making decisions for disabled people. Like, right? There's like the nothing about us without us like the thing, and I just worry as like an able-bodied person, although this is like really good work, like how do we make sure that like it is in the best interest for like disabled people as well?
Yeah, I mean, I think that's a great question to have, and one that we've had since the start of the project, which is why we've been fortunate to interview and run workshops with over 150 people with different types of disabilities, and they're generally very grateful to have these things, although suspicious sometimes of the data. And I do have some future work that I'll hopefully get to, where we're looking at gathering data about your mobility and your ability, and then linking that to the data. Right now, we don't do that, out of privacy concerns, but we have a study, and I have some slides about it. But I think it's a really good question. And again, I think once the data is out there, we can have those kind of caveats and stipulations.
Awesome, thank you.
Yeah. And just to remind you, sometimes people get confused and they think, oh, so you go out with your smartphone and you just take pictures. Well, that's traditional state of practice. There is no on-site data collection with this tool. So we are dependent on Google Street View, but that also allows you to do this from anywhere. So here we have somebody who's in Germany who's auditing a street in Mexico. And then I also mentioned these validation missions. So take a look at this. And the other thing to think about is you might not have personal experience with mobility disability, but in part, I'm also training you right now. So you may have at the beginning of the talk felt a little uncomfortable or unknowledgeable about these concepts, but these are the kinds of similar trainings that we give you in the tool itself. So I'd argue also that we're allowing other people to think about and empathize about the world in a different way through our tool. All right, so this one, is this
another remote question? Amber, do you want to unmute and ask?
Sure, sorry, yeah. I was just wondering, like I was noticing a lot of these Google images, this one's pretty more recent from 2021, but the one in Mexico is from like 2010. Is there concern about the data being too dated, like if there's been a bunch of construction in the area since the Google Maps car went by?
Yeah, and I have a number of slides on that as well. I think that's the number one thing that we do, and we work with community organizations, is we let them know. I run a script, and I have an example of it where we look at the recency of the data. I also will show you that in government data tends to be extremely outdated. So having something that's 2 to 4 years old would be very fresh from a government's perspective. All right, so these are really great questions. You should keep them going, and I'm happy to skip through things so that we can end at 1:50 for questions, because I wanted to give you at least 10 minutes to have a little debrief where we can have Q&A about things as well. So yes, so what do you think? Is this an obstacle? Yes. This one's pretty easy. This is from our deployment in Amsterdam. And yes, there's a pole and a bike. So it's a double whammy. Sweet, Mark, agree. How about here? Also, that's why we always have the timestamps on everything, and everything is timestamped in our data. We have tons of metadata in all of our open data. So yeah, this is a missing curb ramp, tons of other problems. But the goal here as a crowd worker is to just focus on the question, is that a missing curb ramp? And so you'd say yes. How about here? They're going to get harder. So this is a residential walkway. It is not in any way included in the ADA. This is to allow you to have clean shoes when you get in and out of your car. So you would, in this case, Mark, disagree. How about here? Like I said, they're going to get harder. Missing curb ramps are very difficult. It generally requires you, and that's why our tools are interactive, and this is why it's very hard to train computer vision algorithms to do this. You have to look, and you'll notice actually, well, people are using it to cross. Right, so that might also inform your choice about whether to mark it as a missing curb ramp. How about here? Yes.
But it can be used by.
It can be as a last resort, and people oftentimes do use them, but it is, again, doesn't have to be accessible to wheelchair users, and it's designed for cars. So people in wheelchairs do have to use them, but it's an unfortunate consequence of the lack of good built infrastructure. How about this one? Is this a surface problem?
Yes.
No, because it's not on the pedestrian path. And this one is because it's a significant uplift. How about this one? So I know this is tough. What we found, especially in our early studies, if we're like, okay, I want you to label poles. People are like, oh, I'm like, but only the poles that are obstacles. And people are like, well, we're really good at labeling poles. We're not so good at assessing whether or not it's an obstacle. So generally,
in this case, isn't this a problem because the curb cut is not facing towards the actual sidewalk or the crosswalks?
It still
facing
needs,
out into the middle of the street.
Yeah, when we do have a tag for that, but if we got into the details of ProAg standards, this still would meet ADA. But you're right that it's a less safe curb ramp than one that has two curb ramps that are orthogonal, right? That allow people to go in that pathway because, as the person just said, right turning traffic, you put yourself into that traffic line and can cause injuries and fatalities. So this pole is not an obstacle. And again, this is what makes this problem difficult because you have to assess the pedestrian pathway. And in fact, there is this buffer zone, and we oftentimes want that because that gives you distance from traffic, right? So you have to be thinking about that when you're using our tool. And we also try to make it fun and educational. We have these mapathons, we work after school programs, we have leaderboards, which work really well in those contexts. And we have a set of built-in analytic tools. So for example, this is label map. And here we're just looking at a top-down visualization of all the labels, and it's color-coded. And we can also give some feedback for validation. Here's no sidewalk. And you'll probably see that interactive legend on the left side. So what if I only wanted to see the most severe obstacles or the most severe surface problems? So we can attend to that as well. Oh, I'm going to start to play with the severity here. So these are the most severe surface problems now in this community. Those are obstacles. There's an interesting one up here. I think it's a basketball hoop. So things that you just maybe aren't thinking about actually that can impede people. Yeah, right there is a basketball hoop. And then we also have sidewalk galleries. So all of these things have images associated with them. So we can present these sort of interaction paradigms that are already comfortable to people. In this case, it's just basically an interactive photo gallery. And you can, again, agree in a lightweight way. We want to collect as much data as we can. So as you mouse over, we can get instant responses. And you'll note that there's also thumbs up and thumbs down. So those are other people's votes about the accuracy of that particular label type. And again, you can go, this is Pittsburgh right now. And I just clicked on parked car. And so for some reason, Pittsburgh has a really unfortunate pattern of people parking on sidewalks. And so you're seeing that come to light here. So our first deployment was in 2017. And this is what the interface looked like back then. It wasn't all that different, really, but just fewer label types. And a lot of the back end has changed since that time. But here we had over 1,400 users participate. Again, this is that top-down visualization. It's color-coded, so the color codes are on the bottom. Generally, greens are curb ramps. Missing curb ramps are going to be pink. Surface problems are orange, and so on. And there's lots of different ways we could do this. And this is still kind of an open area of inquiry for us. But like, how do we encode this to represent access. So this is one algorithm where we're scoring the streets. We could also do a point-wise visualization. And here we're starting to actually see maybe some patterns in our visual perception system, like these two hotspots might be more salient for you. Or we can combine missing curb ramps, surface problems, and obstacles together and make an aggregate problem density heat map. And again, we see those two bright spots. Well, one of them, if you're familiar with the DC area, this is the Southeast Corridor, Anacostia, which is a lower socioeconomic area, 92% Black. But over here, interestingly, in contrast, is Georgetown, one of the most affluent areas actually of the DC area, in a highly historic area, 82% white. So we have two areas with really inaccessible infrastructure for very different reasons. And one perhaps is due to preservation policies that are trying to maintain those cobblestone roads and sidewalks, but at a cost of accessibility. But this is the potential of data-driven urban accessibility analytics using our data, and all our code and data is open source. So like people start to build tools on top of it. So this is an interactive visualization of DC that was covered by local press. This is a team out of Germany that started using our data in Mexico to develop these access score visualizations. Microsoft's AI for Good team has been using our data to train machine learning algorithms. And we've been a featured project on SciStarter, which is a community science platform for kids, for Girl Scouts and others to utilize crowdsourcing projects like Project Sidewalk. So I want to briefly talk about some of our deployments and partnerships, and then I'll talk about some of the AI and some future work, and then we'll have time for questions. So I think we're doing fine time-wise. So yeah, so we initially deployed this in 2017, and I'm happy to say that we're now in 4 continents, 7 countries, in 21 cities throughout the world, where we have been natively translated into 5 different languages, all through our partnerships, into German and Dutch and Mandarin and Spanish. So it's grown beyond my expectations. And all of this growth is really organic and due to the disability advocacy, walkability advocacy, and others that we partner with in every city. And I'll talk about a few of those case studies, but one was with worldenable.org, which is an international disability advocacy, and the city of Amsterdam. Another was with Liga Peatonal, which is pedestrian advocacy within Mexico, along with their local university. Another one was in Zurich with the city of Zurich, as well as their local university. And generally we grow like this. I get emails, people say, hey, I have a disability. The infrastructure in my town is really horrible, and we'll have a number of different follow-ups. And we now know what sort of ingredients are necessary to be more successful. It doesn't guarantee success because it still takes a lot of work to be successful. I just recently got this one I thought I would share. This is just 2 weeks ago, Project Sidewalk in the Arctic Circle. And so like I said, the first thing I run is a script that gives me a visualization like that. And that's a color-coded map based on the GSV timestamp. So you can see here, most of the data, median age is 1.8 years. So I'll share that information with our partners, make it clear that that's what the data set looks like, and then I'll also do a little bit of a qualitative inquiry by looking at the streetscape imagery. So some case studies. Newburgh, Oregon, this is one of the first ones. We did DC, then Seattle, then Newburgh. This came from 2 disability advocates within the city. And this is also the first time we ever partnered so closely with the city. This is their public works page. And they listed us there. In all, we had 230 users participate, completely mapping and assessing 116 miles of streets. You can see around the periphery, a lot of missing sidewalks as you go down into the core part of the city, some missing curb ramps as well. And as a result of our data and analytics, the city of Newburgh passed 2 sidewalk renovation programs. One was to subsidize all government property with new sidewalks, and a second was for homeowners to try to upgrade their sidewalks. I'm perhaps most proud of this one. This is one of our most recent successes. So this is with Oradell, with a local hospital, the national multiple sclerosis group, that was their local group there, and also the Girl Scouts. The Girl Scouts really drove this project. So through service learning, they learned about urban design and mobility as a human right and disability. And they also presented their findings to the city council. So this is a time lapse. This was work led by Chu Lee, my PhD student. Time lapse of the data. You're seeing, when you see major bumps in the data, that's when we run our mapathons with them. So here again is a top-down visualization. You can also pull this out as a trellis plot, which allows different kinds of patterns to emerge. perhaps the most interesting is if you look at surface problems, and then you look at the lack of sidewalks, you get almost a complete street grid, which means, wherever they have sidewalks, they're not in good condition, or they just don't have sidewalks. And remember, we have tags, so we can see, well, what are some reasons for this? Well, 29% of all surface problems are height differences that look like this. So these are the high severity ones, which are really debilitating. And then we can also see that 7.3% are high severity. So we not just getting that qualitative data, which again is really important when we work with our advocates, they get to see the problem and verify it themselves. But then we can also look at it in these geospatial patterns. And like I said, they presented this work at the city council meeting. This was in January of 2023. So this is still active work. And we did interviews, as we usually do, to try to get insight into how they feel. This is a Girl Scout. Before Project Sidewalk, I never realized how important curb ramps are for people with disabilities. Now, when they walk down the street and see something inaccessible, they quickly notice and say, this is wrong. So they're experiencing attitudinal and behavior change through this experience. This experience gave me a new perspective that I can use to help change the world. And all of this is captured, again, led by PhD student Julie, and will be presented at CHI in Hawaii shortly. And the final case study is in Mexico. Here we did work with the local government as well that said Project Sidewalk provides us with data that is essential to improving San Pedro's urban accessibility. With Project Sidewalk, we know the main problems to be solved, how many problems there are, and their location. The results will be used to inform a new pedestrian master plan for our municipality. And as I said, we have native language translation. So this is huge effort. We have a ton of different interfaces that require native translations. And here's somebody who's using it to label an area in Mexico City. And there's a little interesting part when they take a step forward here, where there's some rocks in the curb ramp. Okay. It's really interesting because, again, once the data is open, people can do their own analytics. So they started looking at the correspondence of pedestrian fatalities along with accessible sidewalks. And they were also featured in the United Nations UN Habitat Report. The other thing to look at, again, is just, wow, what does urban infrastructure look like in Mexico? Well, these are some of the worst rated curb ramps. Take a look at how narrow they are. Some of them are actually marked as accessible, but I would declare that they're really not. But perhaps my favorite one is a fairly new design that they have in Mexico City. Does anybody notice something awry here? How do you go? Yeah, so this curb ramp can really only be entered from one direction. Is that clear, right? Just kind of from here, it'd be a little bit hard to get that way. So again, people think about this, they're spending money, they're going out, construction workers, a lot of money is being spent, but it's not particularly accessible. And then the cool thing is you could do these cross-regional comparisons, you could do it qualitatively, you could do it quantitatively. And this is something that my lab is actively interested in. Okay, so we have maybe 10-ish minutes, 11 or so, to talk about some of the AI things. So we have a ton of data. And if you work in computer vision or machine learning, this should excite you. And remember, part of our original vision was to use this to train machine learning algorithms. So I thought I would share a little bit about this. In fact, we've been working on this part since the very first year, essentially. The first paper was exploring early solutions for automatically identifying inaccessible sidewalks in the physical world using Google Street View. And here we are. And this is actually using SVMs and then eventually deformable part models. This is pre-neural nets, okay? And then in 2014, we were really interested in those human AI workflows. So I'll mention Tome, I thought was a very nice breakthrough for our team. So we did have an automatic curb ramp detector, okay? But this is a hard problem. So we have a true positive here, but then we also have a false positive. And anybody who's worked in computer vision is probably used to seeing these things. And then we have what's worse, is a false negative. Because actually for us, false positives are fairly fast to correct. And I'll give you that. That's the insight behind this system. So essentially we tried to predict the success of our computer vision algorithm with another trained task allocator. And if we thought it was going to be successful, and if it didn't have false negatives, we'd send it to a verifier. And otherwise we would route it to a human for labeling. So this is the verification interface. It's super fast, right? You just pan around and quickly delete the false positives. Or we would throw out the CV labels and just route it to humans for labeling, which is way slower, especially here we were doing polygonal labels. So that's just a much more arduous task. And then we did a user study, lots of labelers. And what you'll find, unsurprisingly, is that verification is way faster. Then we did some baseline comparisons where we had manual labeling only. We had CV versus CV and verification, which is just the top workflow. And we got a drop in performance. And then we had our system, which smartly tries to combine the system. And we found that it generally performed as well as human labeling alone, but it was much faster. Right? So that was 2014. Then in 2019, this is the rise of neural nets. Okay, and so here we're using an RNN, and we got twice as much in precision if you keep recall fixed. So then we're thinking we're doing pretty well. And if you don't mind about recall, which we do, you can get all the way up to 90% precision. And this system was actually trained on all 5 label types, not just curb ramps. So one is we benefited from much, much more training data, which we didn't have previously. And the other is using this ResNet 18. And the cool thing is we didn't just use image features here. We also updated the input vector to have positional features and geographic features. So like, why not leverage other things that we know? So for example, in the pano, where is the crop? Where is the potential problem or accessibility feature? And the other side is the geographic feature. So where is it in the world? And might that help us do a better job of determining and predicting a certain kind of label type? So actually we did much better. There's 2 different tasks here. So the first is auto labeling panos, just like with humans. You move around the world, but now you're an AI agent. And then the second thing is auto validating. So you take human labels and you say, is this right? Essentially, all right? So one task is way easier, so we'll start with this. This, we're giving, the input is a crop around a previously labeled human image. And for curb ramps, we got 93 and 97 for precision and recall, and generally did fairly well for these other things. So this might give us an opportunity to do automatic validation of human labels, right? Which would save cost in our pipeline. Here is panos. We actually use a sliding window and a massive pano. And there's a lot of opportunities for false positives and false negatives. So you're seeing the precision recall curve. And again, curb ramp performs best, but overall, this isn't good enough to actually help our system. This is not shipped in Project Sidewalk yet, right? But on the validation side, and this is an experimental interface, we have the CV algorithm running here, right? And so it could actually assist. We could use it as another vote potentially in our system by combining it with humans. And we've also now looked at the effect of noisy data, which we have, as well as can we go into a city with labels trained in another city? So how well does it generalize? And then more recently, and this is really the holy grail, can we do AI first assessment? So we haven't done that with sidewalks yet, but we have done it with bus stops.
For scalable data collection on bus stop features using real-time computer vision and human labeling. This Crowd+AI workflow speeds up the data collection process and improves data quality. Users are dropped at bus stop locations and presented with its Google Street View.
So here it's AI first pass, human verification. Humans can also add in for false negatives. Right? It's a really nice workflow, and the CV algorithm is actually running real time in the browser. So a little bit like what we're doing on HMDs, but in this case, virtually, yeah.
We also work with like semantic segmentation to zone out the pedestrian versus the buffer zone.
We've done a number of offline experiments with Project Sidewalk, not with this bus stop accessibility project. So the question is, are you also looking at semantic segmentation to try to segment out different features of the world? I mean, this is partly and I don't remember, I have a slide on it here, but this is partly why this problem is so hard. Because again, we don't care if it's a pole. We care that it's a pole that is impeding the sidewalk. So I think there'll be a strong role for semantic segmentation in the future. We haven't gotten it to work well enough for it to be useful. Yeah. And then also just looking at new human AI workflows. So this is with, again, my PhD student, Chu Lee, and she's developing a new interface that uses AI assistance to help you do better as a human. So it intervenes at a time in which it thinks you're making a mistake.
In the label-led condition, when the system detects a mistake, we pop up a just-in-time intervention dialog. The dialog has 3 parts: a mistake title, a rotating set of labeling tips for that label type, and 3 buttons. The participant can choose to keep the label.
These are probabilistic interventions trained with snorkels. We have a set of heuristics, and we then did a controlled study, and we found that it did help, which is great and great news. So we have about 3 minutes, and I'm now graduating to the sort of last part of this talk, which is discussion and future work, but I can easily pause here too for more questions. Yeah.
Have you looked at all like with Project Sidewalk building an app that will allow you to do navigation? Because a lot of people use like, Google Maps for walking routes, but there's no guarantee that that route would be accessible. But it seems like with this data, you could build that into like your navigation planning.
Yeah, I think that would be really awesome, with the caveat that some of our data is old, and that weather and construction and other things that are maybe more temporal or recent could have an effect. But in talking with people through interviews, they don't care. They'd rather have something than nothing, especially if we can show them and say, oh, well, it's not perfect, right?
Yeah.
So I think it's a great idea. We've also been looking at doing some AR head-mounted display navigation stuff too. Is there another question? Yeah.
Have you thought about trying to partner with apps like Strava, where there's already like geotagged people using this app while they're running, and they can just like thumbs down if something was bad, like when you're pushing the stroller.
Yeah.
To as a lightweight way, just get like a bunch of labels that are noisy, but it's a thought.
Yeah, no, I love that. And as a runner, that would be cool. I don't use Strava, I use Runkeeper because I'm like old school. But like that'd be so cool. I'm like on the watch, right? It'd be so lightweight.
You lose all of the granularity,
Right.
but
Yeah,
it
it's something.
Scale,
Yeah.
especially if you're trying to do AI.
Right. Yeah, we're working with MIT right now too, and we're hoping that we'll get grant money to study where people are going who have mobility disabilities through GPS and a smartphone. It tells you where they go, not where they want to go and can't. But I think it'll be a really useful signal as well.
Yeah. To be clear, that would be like for ables.
Yeah, no, I get it. Like totally, like in situ crowdsourcing. Yeah, lightweight. Yeah.
What's the precision level at which the outputs of an AI system would be useful and deployable?
Yeah, it's really. I wish I kind of knew that.
But what's the precision level of crowdsourcing?
It's I don't know the precision level, but I can tell you the accuracy is around 85%, and that's based on validations. So that's based on other humans' perceptions of correctness. So anything that I see in our system where a user has a score above 85%, we think is pretty good. Above 90 is extremely good, but there's also noise there, like I said, because the validations are happening from the same people who are making mistakes in labeling. So we have pretty noisy data as well. Yeah. So it's really important that we get things working with our quality control. Like, you probably saw a lot of my interfaces have agrees, disagrees, and unsures. So we're trying to ensure that almost everything has validation, and the more the better. But that's costly.
And if human beings are, let's say, agreement level of 85% among sanitators, what are the best vision systems doing? Are we talking 10 points behind or like 50 points behind?
It depends on where we draw the line. So we have 7 label types right now.
Yeah.
Curb ramps, we're doing fairly well. But a lot of things like surface problems are so amorphous, and a lot of them are degradations. Curb ramps are designed. And then in fact, they increasingly need to be designed in a certain way. So those are easier. The harder ones are things that are degrading. And then towards your point, it's not just that it exists. It needs to exist on a route, on a pedestrian pathway. And so, as far with the kind of data that we have, like Mapillary is doing great with doing identification of objects, but no one has been able to infer context plus identification. In other words, that it's actually a mobility barrier, right, on the sidewalk path. It's a good question. Or just a couple of things. I mean, a lot of this is just like food for thought. I mean, the holy grail for us, and I had you fixated probably on one little small part of this, which is just accessibility attribute inference. But the other 2 parts here, which is sidewalk topology. Where are there sidewalks and how are they connected is also critical. And this is something that we're collaborating with MIT on. So that's something that my PhD student Shu will be doing over the summer. And that's really the holy grail. It's like you get sidewalk topology automatically and infer where the sidewalks are, how they're connected, and then do a condition assessment. And then one thing I've long been interested in is how do sidewalks change over time? And why do they change? Where do they change? Where are they not changing? Is maybe the most interesting question. So we could use Google Street View for this, and we built some interfaces trying to take advantage of the fact that the built environment doesn't shift very quickly. So we can draw a box here or here, and it's automatically propagated through time to hopefully identify like maybe when that curb ramp was added, right? Again, to hopefully have better accountability, better tracking tools for how the environment is changing. How do sidewalk barriers? This came up already, so I do want to cover this. Sidewalk barriers are a function of your mobility. So we ask people to sort of adopt this wheelchair user notion or persona, but obviously these things are dependent on our mobility, right? And the mobility aid we're using. So we're now doing a large scale study where we're using Project Sidewalk data and we're recruiting people with different types of disabilities, and they tell us about those. And then we do a whole bunch of pairwise comparisons to hopefully build better access score algorithms and visualizations that are much more personalized. We're also, this is a collaboration with Purdue. I know I said we don't really do any data collection particularly, but I think there's some really powerful opportunities in doing drones, LiDAR. This gives you mensuration, so we're getting very precise measurement of width and things that we can't actually do with Project Sidewalk. A big economic driver in the future of sidewalks is likely to be ground delivery robots. So can we utilize these as sensing platforms as well? One issue is that they are also constrained by the very problems that constrain humans. Like, get there. So that would be impossible to a wheelchair user. Can the robot do it? Actually, no. And maybe be stuck there forever till the battery runs out. There is a form of bias within GSV. It doesn't exist in Africa, parts of Russia. You may have heard Germany, it's illegal, and so on and so forth. We've been exploring that and other kinds of data sets like Mapillary and other open data sets that exist. How old are the Street View images? Somebody asked this. I don't remember if it was online or in here. So we track this very carefully. We publish this with all our data. What we found is in practice, it's 18 months to 2 years if it's in a big city. And again, I want to put this in context. This is the DC curb ramp data set. The first time they ever collected it was 1999, then 2005, 2008, 2010. 2010 ellipses. This is what we're dealing with, right? So a lot of times when we're working with our stakeholders, they say something is better than nothing. Something is better than nothing. All right, and then the last thing, and this is more meta, is like, how do you sustain something like Project Sidewalk as an academic? If you've done any kind of open source, this one has 9,526 commits, 152 releases, 374 open issues. I'm deeply grateful to Mikey Sogstead, who's been a longtime research scientist in my group, and he started as a master's student, but I could not do it without him. So I essentially have one employee full-time on the project that's just keeping it alive. And then we have a growing group of community, contributors, 208 members on our Slack. We have a new website called accessiblecommunities.org that I'd love for you to check out, and sort of breaks down the various stipulations and opportunities for using a tool like Project Sidewalk in your community. And with that, I want to thank you very much for your attention. I also want to especially acknowledge the team. So many people have contributed to Project Sidewalk over the years, so many, in fact, that it doesn't fit on a slide. So, and one of the greatest parts about being a professor is honestly seeing student impact. And I was really thankful that one of our undergrad researchers was recognized with one of the most prestigious undergrad research awards, which is CRA, last year for his work on some computer vision. So with that, thank you to our funding. NSF has been a huge funder of this. We started with the Google grant originally. And so, yeah, thank you. Join us. Oh, yeah. I was like, what is that? I was like, that's not part of my slides. Yeah. Other questions? You asked so many great ones.
You ever hear cities saying something like, oh, it's great we have all this data, but we can't actually do anything about it because of budget? Like, how big of budget is it?
I'm going to one-up that 1,000 times. The number one thing we hear from cities is, please don't do this in our community, because you will open us up to the threat of litigation. And I have many, many quotes substantiating that. That's why oftentimes we're working with community advocates and disability advocates like Disability Rights Washington. I wish it weren't that case. And in fact, Yochai, who is an expert, he's a professor who studies ADA transition plans. All they need to do is show effort towards making progress on the ADA, which this tool would allow for, but they're just so scared of it. They're like, no. And there's generally nothing that we can say. This just happened to us on the peninsula. We were trying to collaborate on the other side of the sound, and it didn't work out for that very reason. Yes.
Related, that project in Newburgh, was there already a decision to fund new sidewalks on government properties, and the project sidewalk was used to scope the cost of that, or what did that actually sort of do hearts and minds?
Yeah, I mean, I recently, as I was preparing this deck, I actually went back through those emails, and literally they said your project resulted in the passage of 2 new mandates.
They weren't gonna do that.
I do not. They didn't say that, and I don't have the details to be able to state otherwise. But they were very happy with it, and then I saw, I just did a regular Google search, and I saw the actual policy that was passed, which I thought was quite interesting. But this gets into the socio-political realm. Like, data is just one piece of that story, and it is very costly for cities to do this. But hopefully, they can make more informed choices. So this is one part of that result, and this is for homeowners, which also makes it hard because unlike the road in front of your house, in Newburgh, you're in charge of the sidewalk. It's the same in Seattle. Maybe you didn't know that.
I was wondering if that's sort of too deep in policy for this scope, but so often in municipalities, the sidewalks are not actually fixable by the.
Yeah. So, and that's changing. I mean, I think we'll probably see that change. We were working with Plow the Sidewalks in Chicago, which is another advocacy group clearly around weather. And they were able to convince the city of Chicago to say, well, you plow our roads, sidewalks are just as important. So now that's subsidized. And a lot of those programs actually started in Canada.
Oh, very cool.
Which obviously has long winters as well. So yeah, some wins. Yeah, I am a computer scientist, but somehow I've had to learn a lot about urban design and advocacy. And I spend some of my weeks, I'm spending hours upon hours with these relationships to ensure success. Okay, I think I've tired everyone out successfully. Yeah, thank you so much.